Okay, so this is the lecture about orthogonality of modes. So this is a very important concept because when you're dealing with an MDOF problem, no, sabi natin, uh, for example, gawin natin ano, no, 3-story, no? So we need to find the 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 natural modes, no, of each of this structure, no? And from the previous lecture, mode 1 is normally this one. Mode 2 will be something like this, and mode 3 will be 2 times 1, 2, 3. Okay. Now, this concept orthogonality of modes will allow us to analyze the MDOF problem into an SDOF problem. Okay? MDOF will become an SDOF. Okay? Because it will be it will decouple, no, the equation, no, the equation of, remember, if this is a 3-story, 3 degrees of 3 degrees of freedom, you will be dealing with 3 equations, 3 unknowns. Okay, so coupled equation yon. So with the help of this concept, modal orthogonality, uh, we can analyze the MDOF as an XDOF. Okay, so this is from Choprano, by the way. So the natural modes corresponding to the different natural frequencies can be shown to satisfy the following orthogonality conditions. When the frequency omega n is not equal to omega r. Well, I haven't seen a problem na nag-equal talaga, no? So this is valid, no, na that a certain frequency is not equal to a certain frequency in most problems, no? And this is the orthogonality condition. Sulat lang natin. Phi, say for example, phi n transpose, meaning the transpose of the eigenvector, no, sorry, eigenvector of nth mode, no. For example, we have how many nodes here? We have three modes, okay? So for example, yung transpose nung eigenvector ni mode 1, no, multiplied by the stiffness matrix, tapos multiplied by the eigenvector of mode 2, for example, kaya R, no, meaning magkaiba sila, no? That will be equal to 0. Okay? So same goes with the mass matrix. Phi transpose of the nth mode multiplied by the mass matrix and multiplied by the eigenvector of the art mode. So let's say this is mode 1, this is mode 2, that will be also equal to 0. So yun yung ipoprove natin, no? These properties can be proven as follows. The nth natural frequency and mode satisfy pre-multiplying it by phi transpose R. So i-zoom in ko lang saglit para mas makita. Yeah. So phi transpose R K phi n. So we will multiply pre-multiplying by phi transpose R. Equation 10.2.4. Okay, wait lang ha. Okay, so this is equation 10.2.4. Sulat ko dito. K phi n is equal to omega square and m phi n. Okay? Okay, ayan. So ito yung equation 10.2.4, which is k phi n is equal to omega n square m phi n, no, which came from this. Okay, this one. You remember, frequency or omega is equal to square root of k over m, no? So omega square m is equal to k. And yeah, so multiply both sides of the equation by phi n, you'll have this. Okay, next. So ang sabi dito ay multiply daw natin with, try to maximize this. Okay. So k phi n is omega n square m phi n. Then multiply both sides by phi r transpose. So phi transpose k phi n is equal to omega n square phi transpose r m phi n. Okay? So ito yung nilagay natin both sides, no? Omega n square can take any this position because it's scalar siya, no? Next is the transpose of the matrix on the left side will equal the transpose of the matrix on the right side of the equation. Then so kunin daw natin yung transpose of both sides of the equation. So we will put the bracket here, then transpose natin sila. Okay? Now remember, sa property ng matrix, when you have a transpose, itatranspose mo yung matrix, magpapalitan sila ng position. Right? So therefore, from this equation, magiging ganito siya. Oh, sorry. Phi n transpose k phi r is equal to omega r square phi n transpose m phi r. Okay? So pansinin niyo no, yung phi n nagkaroon siya ng transpose, right? Kasi nga naglagay tayo ng transpose on both sides. But yung position niya mapupunta siya sa magsi-switch sila ng position itong phi r. So that's a property of matrix. Okay? And with that, parang this says that which is similar to this, no? Phi n transpose k phi r is equal to 0. Okay, so therefore we can also write phi n transpose k phi r is equal to omega n square phi n transpose m phi r. Okay? So, color will I choose? So, kanina, ito yung natin. No? Dito tayo nag-start. K phi n is equal to omega n square m phi n. Then, nilagay natin ng phi r transpose. Now, baliktaran naman natin. What if we made this r? Okay? So, ito naman siya. Okay? Para consistent. No? So, therefore, applying or multiplying also by phi n transpose both sides, we're going to have this equation. Phi n transpose k phi r omega r square phi n transpose m phi r. Okay? Which is this one. Okay? Now, ito, no? This one naman, we establish from here, came from here. Right? While ito naman galing dito. So therefore, it shows that these two equation, so the on the right side, ito, they are equal. Okay? So if we rewrite that, omega r square phi n transpose m phi r is equal to omega n square phi n transpose m phi r. Okay, and then transpose to the left side of the equation, we're going to have, so may common factor tayo na ito, right? That makes our common factor. So we have omega r square minus omega n square, then phi transpose m phi r equals 0. Okay? Now, we all know that for most problem, no, hindi ka magkakaroon ng frequency na equal, right? So therefore, this portion is not 0, right? That will not be 0. So therefore, this is equal to 0. Okay? Sorry, hindi ko nasulat yung ano. So that will be phi n transpose. Right? So which makes this formula correct. Now this proves our modal orthogonality. Okay? So pag ibig sabihin, if this is n, this is r, so meaning hindi sila magkaparehas, it will be 0. Otherwise, no, if these are both n tapos n din to, that is 1, no? Or a diagonal matrix. Or in our case of definition, phi n transpose m phi n, ay, hindi nga pala dyan nakasulat. So phi n transpose m phi n will be called the generalized mass matrix. Sorry, humarang. Yan. Okay? Then for the case of stiffness, say phi n transpose k phi n, this is now you called the generalized stiffness. Okay? So that proves our modal orthogonality. Yeah, proving that phi n transpose m phi r is equal to 0 also goes with phi n transpose k phi r equal to 0. Okay? Okay, so let's now proceed with the interpretation of modal orthogonality. We develop physically motivated interpretations of the orthogonality properties of natural modes. basically the physical displacement. No, remember, phi is an eigenvector. So hindi yan realistic. No, it's just a vector of the shape of the modes, no? So in order to translate that into physical or realistic displacement, uh, we multiply that with this q sub n. Okay? So ganun din sa acceleration. The corresponding accelerations will be qn double dot as a function of time times the eigenvector phi sub n. Okay? So one implication of modal orthogonality is that the work done by the nth mode inertia forces in going through the art mode displacements is zero. So which is same concept, no? So the work done by the nth mode, ito nth mode, going to the art mode, so pag pinagsama mo sila, that will be zero. Okay, yung work, no? The work. Pero ito, this is a different what they call this different formula. But another interpretation of this concept is yung Betti's law, no? So Betti's law is one. So for example, if you have, di ba, ito yung mode 1. So yan. Then this is mode 2. Mode 2. So we say this is the D sub 1. Let's say 2-story yan. D sub 2. Ito ay siguro D sub 3. Ito D sub 4. Okay, tapos this is F1. So in short, F1, so mode 1, no? F1 coming from mode 1, I'll make this multiplied by D3, right? So kinuha ko namang displacement coming from mode 2. Yeah? The work done by that is equal to 0. So yun yung ibig sabihin nun, no? So it goes with, for example, I have a force here from mode 2. Say, ito. Ganyan ko na lang F4, for example. So therefore, F4, tapos going to displacement 2, coming from mode 1, so work yan, di ba? Force times displacement, that is also 0. So that's a basic concept na. Okay? So balik tayo dito. So corresponding acceleration, so the associated inertia force, di ba? Force is mass times acceleration. So mass times the acceleration, since we know that the formula of acceleration is m phi n qn of t. Okay. Next, consider the displacement of the structure in its art natural mode. So displacement at r, q sub r of t, phi sub r. Okay, consistent. Ito naman, displacement at nth mode. The work done by the inertia forces of equation 10.52 in going to the displacement of equation 10.5.3. So work. So F times U. Kasi work, di ba? Force times displacement. So from the nth mode, pinagsama, no? At saka from the art mode. Force from the nth mode, F1N, and the displacement at art mode, U sub R, is equal to. Ayan yung formula. So how do we got that? Hirap magsulat dito sa ano. Okay. It was obtained by substituting the formula of force at the nth mode, which is this one, right? And nakatranspose. No, kasi kailangan nakatranspose kasi nga force vector yan eh, multiplied sa displacement vector. So, kung itatranspose natin to, that will become, yeah, ito, this one. Phi n transpose, yan, nagkaroon ng transpose si phi n, tapos m here, and we have phi sub r. Wait lang. Okay, I'll rewrite na lang muna. So, m, alisin ko muna yung ano, ignore na lang muna natin yung sign, no? Q sub n double dot. Tapos itatranspose that daw natin yan, right? Then, multiplied by u sub r, which is the formula is this, no? So, which is q sub r times phi sub r. Okay? Right? Ito, then ito. Now, operating this, we have Pn transpose, yan, M, Q double dot, Q double dot. Yan. And then we have Q sub R, P sub R. Okay, so the phi and transpose, okay, correct, ito yon, no? Q double dot, ito yon, no? Q sub R, ito yon. Okay, then yung phi sub R, nag-switch sila, no? Napunta dito. Okay? Okay, which is, ito yon. Ito yon, yung phi sub R, galing dito. Okay, so, ito naman kasi, these are all, I believe, scalar yan, no? So, ito lang affected, no? So, that's it, no? And knowing that phi n transpose and phi r, as we prove here, is 0, so that means everything here is 0. Okay? So, that proves that proof that the model of using the modal orthogonality relation. So ganun ka effective, no? Ganun ka useful yung modal orthogonality. Okay? So if we will extend further yung concept na yon, another implication of the modal orthogonality properties is the work done by the equivalent static force, no? Kanina inertia force, mass times acceleration. Ito naman static force. Kun is equal to K phi n Q sub n. Okay. Then again, the work Fs of the nth mode multiplied by the displacement at the using the displacement at the art mode, no? So Fs is this, no? K phi n K phi n Qn, tapos ita-transpose, right? So which makes it phi n transpose K Q sub n. Then multiplied by U sub R, which is this one again, Q sub R, phi sub R. Okay, phi n transpose is this. Okay, this one. K, ito yun. Phi sub R, again, nag-switch. No, ito yun. And Q sub n, Q sub R. And again, phi n transpose K phi R, you invoke this, that is 0. Okay, so static force, work done by the equivalent static force is 0, and the work done by the inertia force is also 0. Yeah. associated with the displacement in the nth mode going to the art mode displacement. Okay? So parang in short, hindi mo pwedeng pagsabayin, no, yung nth mode sa art mode. Okay? So dapat consistent. Okay? Otherwise, that will be 0. Okay, so ito pala yung sinasabi kong 1, no? Kapag if na-normalize mo yung mode, phi n transpose mpn will be 1. Okay, yun yung sinasabi ko. But if you denormalize, we call that the what's that? The generalized modal mass, no? Okay. Okay, so let's proceed with the modal expansion of displacements. Phi entrance, remember, diba, U is summation of phi r q r, or diba, phi times q, no, na-encounter niya to kanina. And when phi r are known, it's possible to evaluate the qr by multiplying both sides by phi n transpose m. So, yun, we multiply both sides by phi n transpose m. So, we got now phi n transpose mu is equal to summation of ito, magiging phi n transpose m phi r q r. Again, because of the orthogonality nga, no, hindi pwedeng magsama yung n and r, mag-zero yan. So, we now have phi n transpose mu is equal to phi n transpose m phi n. No, para hindi mag-zero, no? Q sub n. Therefore, Q sub n will be phi n transpose mu over phi n transpose m phi n. So, naiwan lang to, no? So ito napunta dito sa denominator. And remember, this one is the saan yung sinulat ko kanina? Ito, yung modal mass. Okay? So as a sample problem, ito, given yung for a two-story shear frame, determine the modal expansion of the displacement vector u. So meron ka ng, for example, given yung displacement vector, so which is physical na yan, no? Say that's an actual displacement 1 1. Now in this problem we are going to find, or using the formula na derived natin earlier, which is Q is equal to phi transpose m u over modal mass, no? Which is phi n transpose m, phi n transpose m phi. Yeah. Yeah. So madadissect natin yung pinaka-contribution ng bawat mode, no, in getting the physical displacement. No, kasi itong modes are not di ba? Kaya nga u is equal to phi q, no? So from the eigenvector multiplied by the modal coordinates, no, na tinatawag. So using this formula, no, we are able to convert from a what do you call that, modal coordinates, yeah, that's it, modal coordinates to physical coordinates. Yun yung sabihin, no? In this formula we are transforming from a modal coordinates to physical domain, no? To the physical coordinates using that formula. Ayan. So using that formula, phi n, ito yung eigenvector, mass matrix, the actual displacement u from the formula, then again phi n transpose, the mass matrix, phi n, okay? So using that formula, we got this 4/3. And contribution ng mode 2, ito yung kanyang eigenvector, mass matrix, eigenvector, eigenvector transpose, mass matrix, eigenvector. So we got negative 1/3. Okay. So we got this, no, 4/3 and negative 1/3. So yeah, so we got 4/3, 1/3. Where's my pen? Which is this one. So U, physical coordinates, is phi, the uh, the eigenvector for the mode shape 2, and then the Q that we got, 4/3 and negative 1/3. Okay? So yun yung pinaka, we were able to find out the value of Q that we need to transform the physical from the modal coordinates to the physical coordinates. Okay? And how do we get 4/3 again? So, saan lang tayo? Specific natin, no? Here's my pen. Di ba? Ang mode shape 1 is 1/2 and 1. Okay, yan. Ito. 1/2 and 1. 1/2 and 1. So, multiplied by 4/3. So, 4/3. Yan. Okay, naka-transpose pala. Baliktad. So, it should be 1 and 1/2. So, this should be 1, 1/2. Yan. Kasi yung 1 yung nasa top, what do you call this? Nasa top level. So 4/3 times 1 is 4/3. And 4/3 times 1/2 is 2/3. Okay, so goes with mode shape number 2. So negative 1/3 multiplied by 1 and negative 1. Okay. So yeah, negative 1/3 times 1, negative 1/3, negative 1/3 times negative 1, positive 1/3. Okay? So yun yung mga Q values, no? And multiplied with the mode shape eigenvector. Okay, so that's what you call the modal expansion. Okay. So in this simple problem, we were able to, by using the modal orthogonality, no, napakita natin na the total displacements, no, of an MDOF problem is composed of the summation of the displacements from each mode, right? So yun yung pinaka essence nun, no? The by knowing the mode shape, no, the different modes of a structure, we can determine the total displacements, no, by this is already the modal superposition, no, by summing up all the responses from each mode. Okay, so that's it. So yun yung pinaka essence na or ng concept na to. Okay, so which can extend hanggang time history analysis, kaso earthquake engineering na yun, no? So kahit pa ano yun, multi-story building, no, get the mode shape of the building, no, and then by finding this Q value, no, to transform from a modal coordinates to a physical coordinates, we can be able to get the total displacement of an MDOF problem.